Um, so I just gathered some charts and graphs from the first one is actually from a GED test. The other ones I didn't that I found on the sample test I didn't think were terribly interesting. So I got some other ones too for us to look at. So this is your typical bar graph.
Okay.
It has, it gives you an explanation. The bar graph below shows the number of people who visited First Central Bank during a recent week. The bank manager will use the data to make decisions about the number of bank tellers needed each day. So as you look at this graph, you can see, first of all, it gives you a title. Every graph should have a title to tell you something about the data that you find. And then notice that it's got an x-axis. And frequently, when we have an x-axis, we've got time on the x. So what is changing on the x is for a day. What we're looking at to see how does that change. So bar graphs are graphical representations, and I think the most interesting thing about graphs is visual. So you can look at it and see it right away. You can get some idea of what this is telling us. So without really even the numbers.
Can the other one mute her phone? I can't hear you.
Yes. Yes, I will.
Thank you.
So looking at this right away, you can say what? What can you tell me about this graph?
It's about First Central Bank is the number of customers, and then it's the days of the week.
Right. So which day has the most customers?
Friday.
And which day has the least?
Wednesday.
Good. And about how many more people come on Friday than on Wednesday?
About 100. About 100 and about about 100. 150.
So what's the number on Friday?
250.
250.
What's the number on Wednesday?
About 130 or about 120. 110. No.
About 140.
So
70.
from here to here, it goes up by how much?
50.
50.
By 50. And does this
Oh, 25.
Yeah, does that look like it's about halfway? That would be my guess, is that it's about halfway. So 125 compared to 250. How do those two numbers compare? 125 and 250.
It's like one.
Subtract them. You have to subtract.
You could figure it out by subtracting. If you do, what would you subtract?
You would subtract 125 from 250.
Okay, and what's the answer?
125?
Uh-huh.
Okay.
So 125 is how much of 250?
Um, 125. How much is 250? 120. 125 customers. Bank
Yeah.
account.
So I'm thinking about. I want you to how do those two numbers compare? 125 and 250. What fraction of 250 is 125?
250. 125. How would you
Do
calculate
you know
that?
what I'm asking? See how those two numbers compare?
How would you calculate that?
If you 125 plus 125 is 250. 125 times 2 is 250. That means you're doubling 125 to get 250. You could say that 250 is twice 125. Or you could say 125 is half of 250.
You could say 125 is what?
Half of 250.
Oh, so it can be one half. The fraction would be a half.
Right. So because 100 is half of 200, 25 is half of 50. So then 125 is half of 250. Okay. So, or you could say Friday has twice the number of customers that Wednesday has. Wednesday has half the number of customers that Friday has. Um, if you were going to schedule bank managers, tellers, what would
What?
oops,
What's the question?
I'm 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 confusing my own self. If you were going to schedule tellers as the bank manager, what would be important about reading this graph?
Okay, say that again. If you were going to do what?
Schedule employees to work. When would you want to have the most employees?
Would it have something to do with the days?
You will have the most on Friday
You would want the most on Friday. Why do you say that, Tashana?
because Friday has more people that comes in instead of Wednesday.
Sure. So if you have more customers coming in, if you have the most customers coming in on Friday, you want to schedule more tellers or more employees to work on Friday. When would you want to schedule the least?
On Wednesday
On Wednesday, because why, Tatiana?
because only half of the customers come then on Friday.
Sure. So you don't need as many people. They'll be sitting around being bored. So you want to schedule your employees for when you have the most customers. So which 3 days would you schedule the most employees?
Monday, Friday,
And Saturday.
and Saturday.
Beautiful. Okay. So that is information that you can get from a bar graph. I think the most important thing to look at is to look at the intervals and then being able to estimate, because doesn't tell you. Sometimes it'll give you a number right here that will say, this is 225. But it doesn't tell us, so we just have to estimate how much we think that's above. Okay? Let's look at another kind of bar graph. A histogram. This doesn't represent one thing like Monday, Wednesday, whatever. This represents a range. So less than $3,000.
Shh, I got this.
Okay, so here, this is actually a horizontal bar graph, whereas the other one we saw was vertical, went up and down. This one is going sideways, so we call this a horizontal bar graph. And this is actually kind of this turns out to be the title. Share of income spent on an engagement. So this is actually the x-axis. These are the various income categories. And then this is actually the y-axis. Because this is horizontal, it's turned sideways. So this category over here, the share of income, depends on how much income you make per year. So this share of your income changes depending on your annual income. So you are spending $40,000 in this sample of people that they interviewed, spent 2 weeks of their total annual income on an engagement ring. And they're telling you that that 2 weeks is 4%. So they spent 4% of their annual income on an engagement ring. If you made $40,000 to $58,000, you spend a little bit less, 1.9 weeks, the equivalent, whatever you made in 1.9 weeks, or 3.7% of your total annual income. So the interesting thing is, if we think about this as the income, the amount you make in 1 year goes up, you are spending less in terms of percent of your money, of your annual income on a ring, but you might actually be spending more on that ring because 3% of 90,000 is more than 3.7% of 58,000, or more than 4% of 40,000. Does that make sense?
Yeah, it makes sense.
Okay, so if you wanted to double check, one thing that we could do is in our calculator, we could put 90,000 times
3%.
0.3. And why did I put 0.03?
Because it's a percent and not a whole number.
That's right. So if I do 90,000 times 0.03, I get 2,700. Okay, so if I made $90,000 and I spent 3% of my income on an engagement ring, I will have spent $2,700. If I go to 40,000, what would I multiply that by?
Um,
40,000 multiplied by 0.4%.
0.04. So this is a higher percent. It's
okay.
because even though this is a higher percent, 4 is greater than 3.1, it makes a difference. I just took these because these were nice round numbers, 40,000 and 90,000. So this puts me in this category of 40,000, 90,000, but here I spent $20 and here I spent $1,600. Okay,
Mm-hmm.
let's just take 20,000. If we do 20,000 here, again, I'm just choosing that because it's a round number, and then multiply that by, how do I change this to a decimal number, 16.7?
0.167.
Beautiful.
So it would be 20,000 times 0.167.
Yep. If I can get that in my calculator, I keep
So
screwing it up.
3,000. Okay, so they would have spent $3,340 on the ring.
Yes. Isn't that interesting?
Yeah, that's interesting.
That's very interesting. 3,000 times, I think I'm finally going to get it, 0.167. No, I didn't. I'm really struggling here this morning. 0.167 equals, yeah. So they spent the most, even though they made the least. Interesting. Okay. So that's very interesting data. Now we have, that could give us all kinds of questions, right? Like, why are people who are making less money spending more money on an engagement ring? What is that social, um, uh, what is it about the culture, or
They could be budgeting really well.
they could be, they could have better budgets, right? And setting aside, maybe they're saving longer.
Mm-hmm. Probably
Yeah,
making sacrifices.
exactly. Exactly. So that's a very interesting, that then this just tells us the facts. All that other stuff, the reasons why, that's your research project. Okay. Let's look. There's another histogram that goes with this. And now it's telling us how many people. So I retyped this just so you could see. It was so faint and small. I wasn't sure you could see this. But in this, we're back to being vertical. So here's the ring cost down here. What does it mean, 1K? What is that K?
$100,000.
Not 100,000,
1,000.
1,000, right?
Okay.
K stands for thousand because it's kilo, like kilometer or kilogram, kiloliter. That means 1,000. So this is $1,000, $3,000, 5,000, 7.5, 10,000, 15,000, more than $15,000 on an engagement ring. I cannot imagine.
Gosh, that's a lot for an engagement ring.
Well, yes, my husband and I had so little money when we got married that I did not even have an engagement ring. So this boggles the mind to me. It would spend $15,000, but okay. I would be scared to go outside with it on.
Right.
Yeah, that's more than our first 3 cars cost altogether, I think. But anyway, so look at this all the way up at the very top, 250 people in this survey, a little bit more than that, spent how much? See where this dividing line is?
Mm-hmm.
Goes straight up. What do you think would be the number if they had put the number dividing this right here? What do you think that?
I think 10.
Why 10?
Um, I don't know.
Look
I
again.
think I
There's,
think I'd say 10 because all of the zeros, and it's kind of it's counting in tens. It's not counting by no numbers, counting by tens, or it could be counting by 50s.
Alicia, this way.
Okay.
I'm sideways, not up and down. So I have one jump and then I have 1,000.
Oh, 500.
500, beautiful. So let's see if that makes sense. 500, 1,000, 1,500, 2,000. That looks good because that looks like it's about halfway between 1 and 3.
Mm-hmm.
1,500, 3,000. Good. These little jumps right here are all $500. Okay. So how much did 250 people spend between 0 and $500 on an engagement ring?
How much did they spend?
I just told you 500.
Yeah, 500. 500.
Between 0 and 500. So this bar here represents from 0 to 500.
So
This
they
one,
spent $500 on the ring.
yeah, this one represents 500 to 1,000. And how many people about, again, they don't give us an exact number. They're just, they put the bar here, but they didn't tell us the exact number. How many people spent between $500 and $1,000?
Um, I'm gonna say about 215 because the next slide is 250, so that's 200 minus 200. 250 minus 200 is 50. So halfway through would be 225. So I say about maybe 215.
Sure. We could do that each one of these and go down. But in general, what can you tell me about this graph? Just in general, looking at the visual. So we don't have to be real specific, but we can say, in general, most people
Most people are spending less money on rings.
sure. We could even say maybe most people spend less than 5,000 or less than 4,000. We could
Oh,
add up and give a percentage. But the visual it's just a very striking visual that most people spend less than $4,000 on an engagement ring. And
mhm,
then here's something interesting right here, don't you think?
mhm. Just a few is spending 15K.
Yeah. So between 10 and 15, it's just, look at that. It might be 3, 4, 5 are spent between, and each one of these little jumps here. That's only like 1, 2, 3, 4, 5, and then maybe this is 25. So 25 spent more than 15,000. So, but for the most part, it's telling us that most people spend less than $3,000 or $4,000 on their rings. And remember, when we went back and saw that original one, people with less than 23,000, we figured that out to be 3,400. Is that right? We said about 3,400. So even the people here less than 23,000 are making up a big chunk of those. Okay. Let's see. Those are histograms, and the difference between them and a bar, this piece down here is a band of numbers. It's not the same category like that the bank manager Monday. That was one thing, not a spread of things. But it doesn't really matter. You read them the exact same way. They represent data the same way. So, you know, if the difference between a histogram and a bar graph is just in that one little thing there, that this bottom piece is an interval, a spread of data in the same way. These are line graphs. And they show how variables change over time. So if you look down here at the x-axis, we see 1992, 1997. So this is giving us data points in 5-year increments. But we could guess that this is about 1993, this is about 1994, 95, 96. It's not real specific. It's telling us in general, just looking at this, it's telling us what happened to annual ticket sales for different professional leagues. So in general, just looking at this, you can say that which league sold the most tickets.
Which week?
Which league?
Oh, league.
Sport sold the most tickets.
Well, it looked like the major league because it actually goes over the, what is that, 75 million?
Yes. Yes. So these are the numbers of tickets. So, and this, apparently I cut this off, but this should be millions. So 25 million, 50 million, 75 million, good. So the one that is consistently higher is Major League Baseball. And then the next one is Minor League Baseball. Now, what question do you have about the National Basketball? What question is an interesting one?
It looked like during the year 1997 and 2012, the number of tickets bought declined.
Yeah, sharply, right?
Yeah.
I mean, for the most part, this is fairly flat. There's not a lot of increase. It started at, let's say this is maybe 20 million, and it's, over 15. Nope, that's not 15. Over 17, 20, 26 years. It's grown a little bit from maybe 20 million to maybe 23 million. But here are the two sharp drops. What that mean? And if you come over here, it tells you that the 1998, 99, and 2011-12 NBA seasons were shortened by lockouts. So the players stopped. They stopped playing games. It tells you the same thing over here, where this precipitous drop was. Precipitous meaning very sharp. That's another season that was shortened by a player strike. The difference between a player strike and a lockout is, I think the players in baseball decided to stop playing, and I think the manager, when it's a lockout, I think the owners shut down games because, but the reason was the same. They couldn't come to an agreement on how much they should be paid. Like a bazillion dollars is not enough, but you know, that's another story. That those two things they tell you about, they don't mention this. I don't know why there was such an increase in minor league baseball. We would have to go back. What do you think it's going to look like when they extend this graph to 2020?
I think that I think that I think that
It's gonna
the
really drop.
Say that, Tishana, again.
It's gonna really drop because they haven't been having any sports going on.
That's right. There's going to be another note over here, isn't there, that says in 2020, baseball, minor league baseball, and the NBA were affected by a global pandemic, and no tickets were sold or the season was shortened. We'll have to see if that happens in the fall. So far, the National Football League, although it's sold the fewest tickets and it hasn't really grown, has not had a player strike or a lockout. And we don't know what's going to happen with the pandemic, if we'll still be shut down in the fall or not. But that may be, that would be something to watch. So those are always interesting things to look at when you have, like a general trend that has either spikes up or spikes down. You want to know what happened. Like, I would like to also know what happened here. Why did this go up so sharply? And then look, the next season, it took them a while but then they went up and up and up. So those are always good things to take a look at. Okay, where there's a sharp change one way or the other. What would have impacted that? This graph that I found was missing a title. Just looking at that, could you tell me what you think a good title would be?
Tobacco sales
Tobacco sales?
or
A little bit more specific. Tobacco sales.
tobacco products.
And over here, look at what they're telling us.
Is it the children in the school who's using the tobacco products?
Yeah, so you might say tobacco use.
Or we
Okay.
could do teenager tobacco sales or
Yep. And then something else that you could see, if I can, you look right down in the bottom of the left-hand corner, it's only that the source is the Center for Disease Control and Prevention. Of the So you could guess that this was in the U.S., correct? Because tobacco use is very much uh, affected by where you live. So we would want to know that what country at least this was in. And it would be interesting to know even then, was this, because they're not surveying every high school student and every middle school student in the US, they're doing a representative sample. So you would want to know, well, where did they get a representative sample? Is it urban kids? Is this mostly, did they rural kids? Are these kids out in the suburbs? Like who are these people and how did they decide what the representative sample was? So in general, looking at this, what observations do you make about this line graph?
Um, it seems to me that in 2011, um, the tobacco use for high schoolers was kind of pretty much the same.
The same as
Um, the same as like mm, increasing in using e-cigarettes and tobacco products.
so in 2011, high school students' tobacco product use is what for 2000 till 2013? Is it about the same?
Um, no, it's a little bit lower.
Mhm. So in general, do high school students use more or less tobacco than middle school students?
More.
More. In when do you think e-cigarettes came on the market?
In 2011.
In 2011, because it's pretty close to zero here, right?
Mm-hmm.
And that would be, that would be the interesting thing, is what happened to tobacco use when e-cigarettes came on the market. So this is all tobacco products. E-cigarettes. So e-cigarettes are included in here, and this is showing how much e-cigarette use has increased, and what it has done to the total use of tobacco products. So here, 25% or 24% of high school students any kind of tobacco product, and a tiny 20% were using e-cigarettes. So 28% of students have used a tobacco product, and those, look how many of them have been e-cigarettes. So if people were not using e-cigarettes, who knows? Maybe they would still be smoking, but maybe there are some of these people, this gap right here, if there weren't e-cigarettes, maybe this would have continued to go down.
Mm-hmm.
So that's an very interesting piece of this. And so cigarettes were originally introduced to help adults quit, but it became the cool thing, like right about 2013, right? It became the cool thing for high school kids to do. And once they started doing it, look who followed behind, middle school students. So this has been very interesting. I don't know when, maybe you know, do you know when they stopped selling flavored e-cigarettes? I know they did that to stop.
You know, it's been so long since I've smoked tobacco. It's been 4 years. I stopped smoking tobacco when I was 20 years old.
Good
So
for
I
you.
could not tell you anything about tobacco.
I remember that they did stop selling flavors because they said the teens were the ones who were buying the flavors. But I
Okay.
if maybe that was happened here. I don't know. And then why did it tick back up again?
Mm,
I don't know. That's very interesting. But I want to take a look at something else on here. So this is a great graph at slope, which is also what we call the rate of change. So anytime you see a change in direction on a graph, so if we start here, say from here to here, general, what's happening? Anytime you see that, that's a change in slope. So
say that again.
anytime we see a change in direction,
Mm-hmm.
that's a change in slope.
Right, right. Okay.
So what's happening between these two orange lines on this high school, any tobacco product? What's
The
happening?
the slope is going up.
That's an increase in slope, and that would be a positive rate of change. We also
Okay.
say it's a steeper rate of
It,
change or a higher rate of change than
it went
from,
up 10%.
excuse me?
I said it went up by 10%.
Yeah, yeah. So that's much steeper than if we were drawing a line from here to here. There's an increase from here to here, but this increase is much steeper. You see that?
Yeah.
So they are both increases, the but this one is a higher rate. So in 1 year, this went from 20% up to 27%. So an increase of 7%, whereas this one went from maybe 23 to 24, 22 to 24, something like that. So 2 or 3% increase, 7% increase. So that's much higher. So look at this, these green bars. What's happening here from 215 to 216?
Mhm. You said the green bar. It is a negative rate of change in the slope.
Rate of change. Yes, it's a decrease. We're going from, if we look over here at this bar, oh, you know what? I think if I, oops, yeah, I put it up. You
It
can see
decreased probably about 5%.
that. Yeah, I agree with you, Tayshawn. It decreased about 5%. Can you find another that is a decrease, but not as steep?
It's. I'm sorry, I missed the question.
You find another section of the graph where there's a decrease in the amount of percent of students that are using tobacco or e-cigarettes, but it's not as steep as this one, which
Okay.
Tayshawn is about 5%. Where's another section of the graph where you see a decrease?
Okay, what about 2015 to 2017 for the e-cigarettes at middle school?
Beautiful. You're saying from here to here.
Mm-hmm.
Absolutely. And you told me exactly what you needed to tell me so that I would know which line you were talking about. You said e-cigarettes from middle school. So I knew you were talking about this dotted line here. Perfect. And then we could say from 2015 to 2017, it looks like it decreased. I'm going to go over here. Is that maybe 15% down to 14%?
Mm-hmm.
Not as steep a decrease as in 1 year, 5%. Perfect. What's happening here from 2012 to 2013 in between these two pink lines?
It looked like it stays the same.
Sure. And what number do we give that slope?
0.
0. Perfect. It's a 0 because it doesn't change from 2012 to 2013. It doesn't increase, it doesn't decrease, whereas this would be positive 7%, would be negative 5%. This would be 0. Beautiful. And that's what a 0 slope is. It's a horizontal line. It's showing me no increase. Okay. Beautiful. So
I've never seen this before.
you've never seen a segmented bar graph?
Mm-mm.
Good. And we're showing you something new. This again shows us really easily a visual comparison of 2 or more subgroups. So the title of this is 2018, in the year 2018, music consumption by genre. So they're talking about music consumption. What effect does streaming have on the kind of music that people are listening to? And, they always talk about the charts, the Billboard charts,
Mm-hmm.
one on the charts. So
Mm-hmm.
that has traditionally been measured by sales of actual albums or CDs and
Mm-hmm.
downloads. And now that you could, and also by how much airtime it got.
Mm-hmm.
But with Spotify and Pandora and all the
Apple Pay and things like that.
yeah, that had an impact on what kind of music people were listening to, what made it be that way. But anyway, if you include
Say that again.
streaming, which category has the most sales?
If you include streaming,
Uh-huh.
um, R&B and hip hop.
R&B and hip hop. Now look at the difference between with streaming and without.
Okay.
So if we
Wow.
have streaming,
Because it would be the rock without the streaming.
yeah. So
Wow, that's something new.
isn't that interesting? And what do you think this little white place is over here?
It could be room for a genre of music that's not told yet. I don't know.
Exactly. That's the other category. Everything else that's not R&B and hip hop, pop, rock, or country. Um, Notice that all of these, this should add up to 100%. So they don't tell us what the other percent is here, but if you add up 20, 23, 33, 14, and then whatever is left over, this is 100%. So in this kind of segmented bar graph, the entire bar represents 100%. Okay, so whatever the other thing is over here, that would make this all add up to 100%. So the interesting thing is, why? Why does that? What about R&B and hip hop makes it so accessible to streaming, or why do the people who listen to R&B and hip hop prefer streaming? What about that? I mean, that's a whole interesting discussion. This just gives you the facts, the reasons behind it. You know, you have to do some research to find out. But I thought this was a very interesting graph, and you're right. It's one that you don't normally see, and there is, though, another type of graph that you frequently see when you've got percents and single categories like this, very discrete categories. Do you know what kind of graph that would be? There's a kind of graph that we haven't looked at yet that you might
What?
be familiar
Say
with.
that again.
What kind of graph is really good for showing percents like this, percent of a whole?
Um,
A pie graph.
a pop graph. She
Oh
said a pop
yeah,
graph.
a,
A pie
or
graph. I'm sorry.
Oh,
yeah,
a pie graph. Right,
yeah.
with the circles. Okay.
So a pie graph or a circle chart, or a pie chart graph.
Like,
So
like,
I actually went to this little website down here, nces.ed.gov, graphing, and I made it easy. You put in your I put in. So I only did the one because I figured if I did two, it would be so small to see it. I just did the one. It was very easy. I put in R&B, hip hop, 54%, pop, whatever, 19. I just typed this in and it created this bar graph for me in like a tenth of a second. It was amazing. I mean, pie chart for me. Um, I think this is the one that we see much more frequently than this segmented bar graph. And it does a great job of showing you visually. You see right away, whatever that red thing is, that's the most, so it does it's very visual, very easy to see. I think that might be it. Oh no, that's right. I forgot. Okay, so I went back to this line graph to data table because I wanted to show you where this information comes from. Do you know what I'm talking about when I say a data table?
Yeah, it's like a table that has like recorded data. Like if Jimmy had 5 blocks and Rachel had 4 blocks, it would be like columnized.
Yep,
Um,
yep. So it's frequently called in these, when we're doing graphs like this, we frequently call it an XY table. And so I just took this data. I gave it I gave it a title. I made an XY chart, And one column, the X column, is going to be the years, right? Because that's what's on the X-axis. And the Y column is going to be percent of students who use tobacco. I think I did, let's see, we'll see which one I did. So I started off, well, let's look. 2011, 2%. 2012, 3%. Which line do you think I used?
Okay, I missed it. Say that again. I'm sorry. I'm sorry.
That's okay. I said in 2011, I used 2% and then 3%. Maybe, I think I should have given this a better title. 2, 3, 4, 14, 17, and 11. Go back. 2, 3, 4, 14, 17, 11. So I should have given this a better title. What should I have called this on my graph? Whoops. I said percent of teens using tobacco, and it was really percent of high school students using e-cigarettes.
Tobacco.
Yeah,
Okay.
it was the e-cigarette line. But this
Okay.
is the person who created that line graph would have used an XY table like this to come up with that graph. So one of the things that's really critical is that you are able to take these points, 2011, and notice I had to estimate. I said 2, 3, so 2012, I said it was at 3, 2013 at 4. So these are, if you think about this as being on a graph, these are the data points that are used to create this line graph.
Okay.
So here's a point right here, 2011 and, come on, 2. So the year 2011, that's the X, 2%, that's the Y. And that's 1 point on that graph. 2012, come on, go back. Right there.
Ain't even know it.
2012, that's the X, is 3. Okay? So that's
Okay, so is it like basically you made a new graph out of a graph?
right.
Okay.
Is what you that being able to move from graph to table to chart is really important. And knowing which kind of graph that you want to use, what makes the most sense. But that is how actually we went backwards. Usually you start with an XY table and you but being able to go backwards and keep picking from it is an important skill. Okay.
Okay.
All right. And that, my goodness, it's 10 o'clock. Who knew?
Awesome.
Yeah. So very good.